clouds form from tiny particles in the air called aerosols. How this tiny aerosol particles forms the cloud creates one of the single biggest uncertainty in our climate models. That means how we project our future warming of our planet. To study how aerosols turn into cloud droplets, we built a device that recreates cloud-like conditions. And that is why our project name is a RepliCloud, to replicate the natural cloud conditions. So that's our horizontal cloud condensation nuclei counter. The device has two plates kept at slightly different temperatures with water vapor in between to create the right conditions for cloud formation. We are taking the aerosol particles, those tiny aerosol seed particles. They are invisible. They will come in here like this, and they go up all the way inside the instrument where excess relative humidity is being built up. And now, as those tiny aerosol particles will take up all the excess water that we have generated from these two plates, they will grow. And once they come out of this device, there is this optical particle counter, that means the laser. As they come in between the laser, it will scatter the light based on what is the size of the particle. Smaller the size, less scattering; bigger the size, more scattering. In that way, you will get to know if the aerosol particle, the size you put in, grew enough to count as a cloud droplet or not. My path to this work is a bit unusual. I grew up in India, and from a younger age, I was working in garages. So taking motorbikes apart, putting them back together, and then figuring out how the machine works from inside out. And that curiosity led me later into mechanical engineering. Beside that, I was always interested into the skies, to why the atmosphere behaves the way it does. And at some point, the pull became strong enough that I went back for my master's in atmospheric sciences. I want RepliClouds to become a backbone of a next generation scientific instrument for climate sciences. If a good measurement taken out of our device could help to make a climate model a little bit sharper, that type of a contribution I would be really proud of.